All right, here I'm going to continue with B. You should have tried this already. Okay, so I'm going to do this in fewer steps now. So which one are we going to solve for? Let's go 1 and 2, right? Which one are we going to solve to you? So you do a scan and you see that x is equal to 1. So solve for x in 1, basically. So you go x plus 3y is equal to negative 2. I just bring this term over to this side. X is equal to negative 3y minus 2. Okay, so you have that here. What are we going to do next? What do we do with this isolated one? Well, first of all, just keep in mind you solved for the first equation. So then it has to go into the second one. If you solve for the second equation, it has to go into the first one. Like you can't plug this back into 1, okay? Sub negative 3y minus 2 into 2. Okay, so we're going to do that. So 2 says it's negative 3x plus 5y is equal to 6. And here we go. So we have negative 3x. And so we basically plug in negative 3y minus 2 in for x. Okay? And notice that I have nothing but y variables left. That's how you want that to be. Okay? So let's distribute this, right? You always distribute. So that's 9y plus 6 plus 5y is equal to 6. Okay, let's combine our y's. So that would be 14y. And let's bring this over to the other side. So that'd be 6 minus 6. So 14y is equal to 0. And even if you divide up both sides by 14, y is equal to 0 still. So we're going to box that in. Okay, so we know that the y variable of this system, of the solution to the system, we know that that is 0. So basically you're saying, okay, the solution is this, but I don't know what the x is. So how would you do that? Okay, well, you plug this into one of the two equations there. So you choose sub y is equal to 0 into 1 or 2. Which one do you choose? I think I'm going to choose this first one. So we have x plus 3 times 0 is equal to negative 2. X is equal to negative 2, right? And that's it. So we're going to box that in, verify. Verifying is very important, especially because you could be making mistakes here. And if it doesn't pan out, you know you made a mistake. So left-hand side, right-hand side. And it's actually, let's see here. It's 3:24:25 for the video. So let's see how long that takes. So left-hand side is x plus 3y, negative 2. So you plug in negative 2 and 0. You got to be very careful. X is negative 2 and 3 times 0. So that is negative 2. Left-hand side is equal to right-hand side. Okay, done. Then you have left-hand side here, right-hand side for the second equation. And that is negative 3x plus 5y is equal to 6. So that'd be negative 3 times negative 2 plus 5 times 0. So that is just 6. Left-hand side is equal to right-hand side. And you're done. So the solution is negative 2, 0. Make sure you don't mix them up. You don't go 0, negative 2, or whatever. Okay? And then always state, right? I'm going to put a note here. State solution as a coordinate point after verifying. Okay, you have to, after verifying, state it as one point, right? So here you're just on your journey. Once you've verified, you can actually put these together it's 1 point. It's not like finding the x-intercept, right? If you find y is equal to, okay, that's my y-intercept, then my x-intercept, those are two separate points. Here you're on your journey to finding that 1 point of intersection, okay? So let's see. Okay, so this is our last example before we do elimination next. And if you, as you can tell, this is ugly. This is ugly, but it's actually not too bad. You just have to take it one step back from where we used to be. And what you do is, I'm going to put a little note here, right? We multiply, don't forget this method. You multiply both sides of equation by a common denominator, okay, to eliminate fractions. Okay, you have to do that, otherwise it's going to be very, very difficult to do. So oftentimes just multiplying these two works. So 2 times 3 is 6, right? 4 times 3 would be 12, and so forth. That often works. It might not be the lowest common denominator, but it definitely always works. Okay, so if you had 2 and 5, right? 2 times 5 is 10. If you had, right, 3 and 7, right? 3 times 7 is 21. That works. So it works. So just keep in mind. So what we're going to do here is we're going to multiply everything by 6 in this case. Okay. So if you do that, right, you basically get 6 times 1/2 is just 3x. 6 times 2/3, right? Well, you go 6 times 2 is, just 1 second, my timer. Here we go. 6 times 2 is 12, divided by 3 is 4. So that's positive 4y. And then it's just -6. Okay. This one, the common denominator here is 12, right? So 3 times 4. So we're going to multiply everything by 12, and you get 12y. You're doing that to everything, right? Is equal to 12 times 1 is 12, divided by 4 is 3x. And then you have 12 times, well, sometimes it's easier to first divide, right? 12 divided by 3 is 4. 4 times 5 is 20, so that'd be -20, like that. Okay. So you essentially have created three equations 3 and 4, right? This would be 1 and 2. It's just to label them. These are actually the same. These two are the same. These two are exactly the same. Okay, it's just to keep them apart. So now what? So now you're looking at it, it's like, well, both of these equations don't have no term with coefficient of 1, right? Like, what's going on here? Like, there's no coefficient of 1 there. And even if you tried to divide everything, you would end up with fractions. So that's not good. But notice that you have this, okay? You have a 3x and a 3x. And that is what we're going to use in this case to make our lives a little easier. I know that in the video study matrix, they made you do both equations solve for x and y until you have no fractions left or whatever. This is the method that gets you by, okay? And so what we have here, and once you do elimination method next, you'll have two methods to choose from algebraically. So you're not going to have to worry about the fraction portion that they talk about, which is not ideal, okay? So both have, right? Notice both new equations have a common term of 3x, okay? And that's good. That's what we want. So what we're going to do is you solve one of them for 3x, right? So let's say we're going to solve equation 3 for 3x. What does that mean? Well, we're not going to have x is equal to something. We're just going to have 3x is equal to something. So we're basically isolating 3x, okay? Which is somewhat counterintuitive. You haven't done that a lot, but it's the easiest method in this case. So we're going to just bring the 4y over, so 3x is equal to negative 4y minus 6, right? So 3x is isolated. X isn't isolated, but 3x is. So we're going to sub 3x is equal to negative 6 minus 4y. Sorry, it's okay to flip it, but I'm going to keep it consistent. Into, we're going to sub that into equation 4, okay? That is important that we're now dealing with 3 and 4. We're not dealing with 1 and 2 anymore. And let's see, I might run out of room here if I do it, but let's go with it. So you've got 12y is equal to 3x minus 20. Okay, that's right from here. Okay, then I go 12y is equal to, what's 3x equal to again? Well, it's right there. It's negative 4y minus 6. So let's put that in brackets for now. Okay, negative 4y minus 6. And then there's the minus 20. So notice that we've substituted this into, because if 3x is this, then we can just say, well, let's get rid of it and just plug the whatever 3x is equal to into this. Okay, so I'm going to bring this over here. Okay, so 12y is equal to negative 4y minus 6 minus 20. I'm going to bring the y's over because I'm going to isolate for y here. So 12y plus 4y is equal to negative 26. And this is 16y is equal to negative 26. We're going to divide both sides by 16. Y is equal to negative 26 over 16. I can divide them both by 2, so that's negative 13 over 8. Yeah, it's messy, but that's okay. Just simplify your fraction, right? So now we're going to verify, or we're going to find, we have y, we need to find x. Sub into 3 or 4. You could sub it into 1 or 2, but that's just too ugly. So I'm going to pick the first one there. 3x plus 4y is equal to negative 6. 3x plus 4. Notice that. I will make a note here. I already know where this is going. I saw an 8 here, and if you look at, right, the 4 and the 8 will cancel out just nicely, even though the 12y would also have worked, right, simplifying it. So it really doesn't matter. But what you just plug in negative 13 over 8 is equal to negative 6. And then you get 3x is equal to, in this case, this is multiplying, so 2 goes in here. Oh, sorry, 4 goes in here 1 time, 4 goes in here 2 times. So this ends up being, sorry, why do I have equal there? 3 plus, this is just negative 13 over 2. And that's equal to negative 6. Okay, so 3x minus 13 over 2 is equal to negative 6. 3x is equal to negative 6 plus 13 over 2. And so I'm running short in time, so you bring this over, adding, this turns into negative 12 over 2, so that's positive half. You have to divide both sides by 3. And notice when you do that, you actually put a 1 here and you multiply the outsides to get the top number and the insides to get the bottom. So x is equal to 1 times 1 is 1, 2 times 6 is, sorry, 2 times 3 is 6. So it's 1 over 6. And there's your solution. And there's your homework